In this problem, we're going to look at probably the most difficult part of our process for solving word problems. When you start your word problem, you define X clearly and completely, and then it says write the other quantities in the problem using X. That's the part that most people have trouble with, so we're going to take a little special time and do a podcast just on that one part. And this is called using a single variable to represent multiple quantities. Now, we're not going to try to make problem excuse the cough there. We're not going to try to make problem solving experts out of everybody, so we'll just be talking about 3 or 4 little principles to use and going over them with several examples, and we'll limit our word problems to those cases. Okay, let's take a look at the first one. What happens when you are given the total of 2 or more quantities? That is, the sum. Total in this case would mean, oops, pen not working. Let's fix the pen up. Total would be the sum of the 2 or more quantities. Well, the principle here to use is that if 2 numbers come to sum total, we'll call it T for total. If you add them up and you get this T, and you let one of the numbers be X, the other one is T minus X. So let's see how that principle applies in some actual examples. It says, in the problems that follow, write all the implied quantities using only one variable. So in the first one, it says you have a problem where a 25-foot rope is cut into 2 pieces. Well, if the rope gets cut into 2 pieces, then there are 2 quantities we're talking about, the shorter piece and the longer piece. So if I let the shorter piece be X, then I've got the total of 2 is the length of the rope. Let's say the rope is 22 feet. That's just a number I pulled out of the air. Suppose you have a rope that's 22 feet long, you cut it into 2 pieces, and you want to represent the length of the 2 pieces. The principle says if 2 numbers total 22 and one of them is X, the other one would be 22 minus X. So this second piece would be 22 minus X. Let's take a look at the second one. Here, instead of a total of 2 pieces of rope, we have a total investment. $4,500 is invested, part at 6%, part is 8%. So this time, instead of 2 piles of rope, we got 2 piles of money. We got money at 6%, that is, it's earning 6% per year, and money at 8%. And when you add the 2 together to make the total is $4,500. So if I let X be the amount of money invested at 6%, then according to my principle, 4,500 minus X is the part invested at 8%. Let's take another look at where 2 things total. This time we've got 2 amounts of liquids in 2 separate vials, and we pour the 2 vials into an empty beaker. The beaker contains 70 milliliters, so when we took the liquid from the first vial and we added it to the liquid from the second vial, we ended up with 70 meters. So our principle would say if 2 numbers total 70 and one of them is X, the other one is 70 minus X. So let's say let X be the number of milliliters in the first vial, then 70 minus X is milliliters in second vial. There it is. If two numbers total 70 milliliters and one of the numbers is X, then the other one is 70 minus X. Now we do a little bit more complicated one. It says a bill for $135.50 was for the monthly charge and the minutes charge. So if I say let X be the monthly charge, then $135.50 minus X is the charge for minutes. Now, if you knew that, for example, the total minutes was 600, you could now do a per minute charge because you've got here the amount of charge for those 600 minutes. Now, the second type of problem I want you to consider is where a certain number, now that number could represent any kind of quantity, might be money, might be weight, might be length, temperature, but a quantity of some kind is increased by a percent or decreased by a percent. Well, here's the principle, and I'm just going to use 12% to make it easy to write up the principle. If x is increased by 12%, the result will be x plus 12% of x, or 0.12x. And when you add x to 12% of x, you get 1.12x. That's because x is the same as 1x, which is the same as 1.00x. All of those are just 1x. And so if I take 1.00x and I add it to 0.12, or 12% of x, I end up with 1.12x. Now the opposite of that happens if it goes down by 12%. But in this case I didn't use 12 because I didn't want you to think that this was only for 12%. So I said suppose x gets decreased by 23%. Now what we really mean there is x gets decreased by 0.23 of x. When you say x gets decreased by 23%, part of the sentence is left out. It means x is decreased by 23% of x. So that's the 0.23x. And again, that's the same as 1.00x minus 0.23x, which is 0.77x. So let's take a look now in some examples that might appear in a problem of what that would look like. Suppose you have a problem where it talks about a number increased by 20%. If n is the number and you increase it 20%, then 1.20n would be the number increased by 20%. Okay? Suppose a certain weight is decreased, this time decreased, not increased, decreased by 35%. If W is the weight and it gets decreased 35%, then 0.65W is the decreased weight. Okay? If it goes down 35%, then 65% of the weight remains. Now, the next one's not quite so clear. It doesn't say increased, doesn't say decreased. It says he paid a 6.5% sales tax on the item. Suppose C is the cost of the item. If you pay a sales tax, that doesn't reduce what you pay, that increases what you pay. And 6.5% translates to 0.065. So what we'd want to do is take that cost and multiply it by 1.065. This would be the final cost with tax. The 1 in the 1.06 represents the whole cost, and then the 0.065 represents the sales tax that was added for a total of 1.065 C. She bought the skirt at a 20% off sale. If you save 20%, you pay 80%. So if P was the original price, then the discount price is just saving 20%, so you're paying 80% of P. He needs to lose 15% of his body weight. If W is his original weight and he loses 15%, that's like a discount. So that's going to take 15% off of W. So his final weight is 0.85 W. That would be 1.00 W minus 15% of W, and that's how you'd get the 0.85 W. Give ourselves a little bit more room here. Now here's an interesting one. Pay close attention to this one. It says after his retirement plan lost 40%, it then went up 40%. So let's say A is the original amount. Then 0.60A is the 40% reduced amount. Now, it says he first lost 40%, so that means that instead of having A now, he only has 60% of it left. But then he went back up 40%. You'd think if you went down 40% and then you went up 40% that you'd be even again, but actually that's not true, because the original amount is not what's going up 40%. It's this reduced amount. So let's see what happens. If I start with an amount of 0.60A and I go up 40%, that's a 40% increase. So I multiply that by 1, that's the total amount of 0.60A. 0.40, that's adding the 40%. Well, what do I actually end up with? Well, 6 times 4 is 24. 6 times 1 is 6 plus 2 is 8. I end up with 0.84A. That is, if I lose 40% and then I go up 40%, I don't go back to the original amount. I've lost a net 16%. So I've only got 84% of my original amount. That going up 40% did not get rid of the going down 40%. In the last one, we talk about sales tax. In problem number 4, we talked about a person getting 20% off price. And we said, well, if she saves 20%, then the price after that is 80% of P. Well, what if she then pays an 8% sales tax? That takes that 80% of P and increases that amount, not the original amount, not the P, the price of the skirt, but the 80% of P, which is what she's paying. That gets increased 8%. So you have to multiply that by 1. That's the whole 80%. And then 0.08, that increases it by 8%, because 8% translates to 0.08 as a decimal. So that would be 1.08 times 0.80p. The 0.80p is the 20% discount, and the 1.08 multiplying by that adds the sales tax on to the discounted price. Okay, let's take a look at one last thing. We just call these, I just call them general examples. These don't fall under the original 2 categories. These are just kind of general things that come up. The first thing I want to do is talk about what are called reversing phrases. When you have a problem in which a certain number is added to n, you can put the number in front or in back, because addition is what we call commutative. The order in which we add doesn't matter. The order in which you subtract does matter. So let's take a look at some words that would lead you to subtract. It says the second number was 24 minus the first number. So if I say let x be the first number, then the second number is 24 minus the first number x. Now, a word that's kind of the same as x but not used as much is the word less. Again, if I say let x be the first number, this says the second number was 24 less the first number. So 24 less the first number is the same as 24 minus the first number. So again, that's 24 minus x. But there are certain words you use in subtraction which causes the order to change. And the first of those I want to look at starts with the word less, but it adds the word than. Again, I'm going to let x be the first number as in the first two examples. How would we write the second number? Well, if it says the second number is 24 less than the first, less than is a reversing phrase. The 24 will, since it appears first in the sentence, will go last in the expression. And the first number, since it was last in the sentence, will go first. So instead of 24 minus x, like in the first two examples, using the word less than would cause that to change to x minus 24. Now, it's not just less than. It's anything that means less than and has the word than in it. So if we were talking about temperature, we would say cooler than. If we were talking about height, we would say shorter than. If we were talking about weight, we would say lighter than. All of those mean less than. So they would all work just like this. There are two other reversing phrases. The three reversing phrases are less than and subtract from. Subtract first from second. And then the other one deals with division. It's a reversing phrase. It's divided into. If you see one of those three phrases, that's a reversing phrase. Like if I said 24 divided into x. 24 divided into x. Since that's a reversing phrase, the x would go first, the 24 would go second. The cost of gas double. If C is the original cost, then 2C is the doubled cost. The second rope was 2/3 the length of the first. If L is the length of the first rope, then 2/3 of L is the length of the second rope. These are just kind of common sense, but read them, make sure they make sense to you, play it over if it went too fast. Let's try a more complicated one. He got the shirt using his $5 coupon at a 20% off sale. If C is the original cost of the shirt and he's at a 20% off sale, then he's saving 20%. And when you save 20%, you pay 80%. So 0.80C would be his 20% off price. But then he used a $5 coupon. That is, he got an additional $5 off. So how would you take $5 off of this new price of the shirt? You just go -5, like that. So there's your 20% discount. So he paid 80% of the cost, and then he took off another $5 because of his coupon. The 3 trophies cost a total of $115. The first place trophy cost $5 more than twice the cost of the third place trophy. So how would I do the 3 trophy costs? So suppose I say let X be the cost of the third place trophy. Now we've got a hint about the relationship between the first place and the third place. It says the first place trophy is $5 more than. So I'm going to put here the cost of the first place trophy. And it says it's $5 more than. So I'll put 5 plus for 5 more than. twice the cost of the third place trophy. Right here we said X is the cost of the third place trophy. So twice the cost of the third place trophy would be 2X. So here we have the cost of the first place trophy. Here is the cost of the third place trophy. What would be the cost? I'll put it in the same relative position. Cost of second place trophy. Well, this is kind of like the two numbers totaling T, but there are three numbers. But if I put the cost of the first and third together, that would be the cost of the first place trophy plus the cost of the third place trophy, which is right here. And if you add that to the second place trophy, you get 115. So our principle was, if two things total 115 and one of them is X, the other one is 115 minus X. So here we have two things that are 115, and one of them is 5 plus 3X, which is what you get when you simplify this. So the other one, the cost of the second place trophy, would be T minus the cost of the other two trophies. So that one you need to think about for a bit. And that completes our preparatory podcast. Now go on to the next one and we'll actually solve some word problems.